Good morning, everyone, and welcome back to day 3 of our faculty development program on blockchain technology and its applications. We hope you all had a refreshing start to your day as we now continue our journey into the world of cutting edge technologies, transforming industries, and research. To begin today's first session, we are privileged to have with us Dr. Dinesh Singh, sir, Associate Professor, Department of Computer Science and Engineering at MNIT Prayagraj. Dr. Dinesh Sir's research interests include vehicular ad hoc networks, VANETs, edge computing, data mining, and machine learning. He has guided research scholars and published extensively in reputed international journals and conferences. Today, he will be sharing his insights on the topic blockchain and fog computing, exploring how these technologies can collaboratively enhance data security, transparency, and efficiency in connected systems. Now, I would like to invite Head of Data Science Department, Professor Prashant Kumar Mishra, sir, to present a token of appreciation to our esteemed speaker. Let's give a huge round of applause, guys, as we welcome Dr. Dinesh sir to enlighten us with his expertise.
This topic is blockchain in parallel fog computing. So firstly, I explain you what exactly the topic is and what we are trying to achieve in this discussion, this lecture. So as you see, this name of the title, blockchain in parallel fog computing. So nowadays, one big issue with all of us technology people is the computing. You all studied the different generation of your computer systems, right? So as we start the journey from the first generation to nowadays, so we try to achieve as much as computing in our resources, in our laptop machines. Definitely, we achieve a remarkable improvement in terms of the computing, but it remains a big challenge in terms of computing itself nowadays, because the computing facility, the amount of computing facility we require, that they require for different application, definitely we are very much, and we have to pay lot of the cost for this computing, right? Even if you you all purchase your laptop. So the cost of your laptop, I think if you see, so you find 1 lakh, 1,20,000. If you go with the higher computing laptop, so the prices may be 2 lakhs or something more, right? The reason is why you need such type of facilities. Being a very first year student, or even if means 10, 12 student is sufficient to work with the laptop of cost of 60,000. If you are in the BTech, sometime you need some higher configuration laptop and you have to pay something more, right? Now once you go in further higher studies, means PG courses, PhD courses or some other, you need some more computing, because the data that is generated from the different applications, right, the amount of data, right, that is very, very large, right? You are not feasible to do the computation with that data on your standard laptop machine. It's not be possible, right? And if you test, if you are the students, so if you run some data science application on your machine, sometime you faces such type of difficulties, right? Your RAM not responding, right? So how you do this work? And this is not a occasional problem. This is very usual problem, right? Because now we have a huge amount of the data in different forms, right? So to process that data, definitely we need very good computing facility, right? Right? So in that dimension, only the support from the hardware is not one solution, right? Because if you go to increase the hardware, you have to pay much more. So what the other solutions we have? We need some software based solution, so that without paying much more cost, we can handle this computing facility. So in terms of software based solution, we have different algorithms with good efficiencies, right? So we can use with the available hardware, and we try to manage this trade-off. Trade-off means cost and the amount of the computing facility, right? Because ultimate challenge is, if we get something in the minimum cost, our job is over, right? Means we are successful in our job. That's the objective of our technology people, right? Design some product, design some application, design some service with a minimum cost, right? That's all objective for all of us, right? So how we achieve that objectives, right? So some software based solution we have. Now these software based solutions are, because computing facility required for every domain, right? One domain, application domain, we are considering, that is a vacular domain, communication. Vacular communication nowadays are very, very popular. Why it is a popular? You see, heard news is very recently that Tesla has designed a self-autonomous car, right? In foreign countries, some countries, it is now be practically implemented and works very fine, right? So that is a term we use. The term is eye off, mind off. Eye off, mind off, right? Means once you inside your car, leave it all the things, you just sit it down and car move, taking all the decisions. No use of the driver, nothing, right? Can you imagine such facility? It's very difficult, right? Although it is not be practical nowadays in our country, but some countries tested this project and they are successful in their job, right? So once you imagine this application, the amount of data that machine, that vehicle capture from the environment and how rapidly it do the computation and taking the decision, right? It is a very important, right? Because in this application, if a small fraction of time lacking, so many lives are in danger, right? Correct? So a very challenging for the research people, technology people to successfully implement this project. So vacular communication and the computing in this domain is very common nowadays, right? Now you all heard a one term, that is a cloud computing, and many times you are using cloud facilities of different service providers, right? Cloud facilities, you all are aware about the cloud facility. Now there is another term, a word, that is a fog computing, right? We discussed. So there is another paradigm of computing model, another model, right? Cloud is one model. The basic objective of cloud is just what you uses, what type of service, the amount of service you uses, from that you have to pay as per the amount of service you use it, right? Because we have no sufficient computing. If we increase the amount of computing in our local machine, we have to pay very much cost. That's why we move on the cloud, right? Cloud, because clouds are very good computing facility and we can access that facility by paying a small amount of cost. That's why we are rely on the cloud. Nowadays this is very popular model, fog computing. Fog computing, so we will discuss what exactly the fog computing is, right? So we use this fog computing in the vacular domain, right? Vehicles receive the input from the environment, different types of the input data, may be some image, may be some voice messages, right? May be some environmental parameters of your road and parameters of some environment, right? So many type of the data you have. You say some multimedia data, right? That the computing device on your vehicle receive, right? So how we process this multimedia using the fog computing model, that is a very important research topic nowadays, right? Now another story comes, that is a blockchain. So I hope you last 2 days you studied the fundamental of blockchain. So I am not going to discuss very much about the fundamental. We are just discussing exactly how you use the concept of blockchain in this vacular fog computing environment, correct? So blockchain is, simple terms, is a security mechanism, very abstract level definition. We can say it's a one of a security tool, right? Correct? So we perceive the data from the environment, multimedia data from the environment. That data faces so many types of security issues, right? Only time lacking is not one issue. There are some other issues. Some attacker, let's say you perceive some data, some attacker modified that data. So your machine take decision on the updated data. Definitely that may be wrong, that is a wrong decision, correct? That is a wrong decision. So how you save your system from such type of attack? There is a long list of type of attacks. So how you secure your system from such attacks, right? So that your design implemented project working very fine, right? So we use this security solution, blockchain solution in this domain, blockchain and vacuolar fog computing. I think you understand the title of this discussion. May I write? Okay. सो क्या स्लाइडर मिलेगा क्या? पीपीटी स्लाइडर मिलेगा क्या? हाँ, एक सेकंड. चलिए. क्या वहीं जाना? कैचअप नहीं कर रहा क्या? So like cloud computing, fog computing itself is a model of computing, right? So fog computing is a storage, computing and networking resources closer to your end devices, right? Now what happens previously in terms of cloud, you give the input to your cloud and cloud is doing the computing. Sometime it is treated as a storage, right? Some temporary data after computing cloud generate, it is stored in their own storage, right? Sometime cloud itself have some network of interconnected devices. Cloud itself is a, if you assume cloud as a single entity, so that single entity may have or have n number of the computing devices, right? So if n number of the computing devices, there is a internetworking among those devices. So cloud providing the facility of storage, providing the facility of computing, provide the facility of networking. So as similar to cloud, we design another model, that is a fog model for the same purpose. It doing storage, it doing computing, it also provide the networking facilities, right? So if the similar model, so what the advantages, why we go to design this fog computing model? The simple advantage, our objective is to making all these threes very closer to the end devices, right? Means if you feed the input to the cloud, right? So if you run some small application, simple program like adding the two numbers, right? And if you, let's say you use the online platform, right? You add up the two numbers, you get the output at the same instant, right? Using the cloud facility, right? But if you implementing some research work on the same platform, you see so many types of session breaks in the session break. Cloud itself showing some malfunctioning sometime. As much as data, input data algorithm you run on that cloud, if you tested, you identify the kind of problem you receive from your cloud. The reason is the distance between your machine to the cloud is sometimes is very large, right? Large distance, that's why there is a term time or simple technology people term this is a latency, right? So latency is very high. One thing we have, because we are running big application, so it consumes lot of the bandwidth. As the distance is high and the size of application is also high, so it definitely consumes lot of bandwidth, right? So what we try, the basic objective to achievement with this model, minimize this distance, minimize the distance of the end machine with the cloud, right? So in this objective we design this 3-tier architecture, abstract level diagram, abstract level 3-tier diagram. So you see in the very bottom in this 3-layer architecture, so this is your bottom layer, this is your middle layer, and this is your top layer, right? Because we are discussing the vacuolar application. So in this vacuolar application, our bottom layer devices, computing devices, are our vehicles, right? Vehicles, right? Such vehicles have their small amount of computing facility as well as communication facilities, right? Communication with their peer devices, communication with their higher level devices, right? So that is your bottom layer. This middle layer, I think it's not be very much visible, this middle layer have the roadside units. Middle layer have the roadside units. Roadside unit is a fixed infrastructure installed inside of your roads, maybe a traffic light pole or maybe any other fixed infrastructure, right? Right? So if you assume traffic light poles as a roadside unit, right? So vehicles are delivering the data to these roadside units, and above of this roadside unit is a cloud. So previously what happens, vehicle directly communicate with the cloud. So you say that distance is somehow very large. So what researchers try to achieve, they try to make this cloud similar to cloud facility close to the end user, right? That's why they try to achieve another virtualization layer like middle layer, right? So why we put up our job to the cloud, if similar facility we achieve very near to our devices, so we try to do the computation with these devices and retrieve back the result. So our job is easy, right? Job is easy. So we get so many advantages, right? So that is a fog computing model. This is a computing model, fog computing. So fog means it's a, sometime it is a fixed infrastructure, sometime it may be a dynamic structure as well, right? Right? Dynamic structure as well. So if it is a dynamic, because the name is a dynamic, and the name of the fog is from, right, from core, from cloud to core, right, from core to computing. So there are so many advantages. You can reduce the latency, you can handle the bandwidth, utilize the bandwidth very well, you can manage your mobility issues, right, mobility issues as well, and you can achieve a good connectivity with your network that you are not able to achieve previously, right, because vehicles previously communicating with the cloud. So most, because vehicle scenario, the speed of the vehicle is very high, right? You know, 150 kilometer for the SUVs is a very common, right? So if someone is moving with the 150 kilometer, the signal strength and the communication skills the machine is doing,
right? And you have to take the decision with that higher speed, right? Very, very big challenge, right? Very, very big challenge, right? So that's achieved by the one model, that is a vacuolar fog computing model. So these are some important objective. So we achieve so many advantages. So there are some important terms in this model. So mobility and connectivity is in one issue. High mobility. In the high mobility, we have to handle the connectivity very well. Resource heterogeneity. Resource heterogeneity means different types of resources you handle. Previously, vehicles communicate with the cloud only. Now, vehicles communicating with the roadside infrastructure. Sometime roads, because there are different types of road structures. Sometime light pole may be treated as a road structure. Sometimes some other infrastructure treated as a computing device, right? So you got a heterogeneous environment, right? Heterogeneous environment. So designing some protocol in heterogeneous environment again be a kind of challenge, right? And the third one is offloading and scheduling. Offloading and scheduling. Now scheduling is a common term that you find, right? Scheduling is very common. So in your operating system course, you studied so many types of scheduling algorithm, correct? Correct? Right? Okay. So where in your machine, where you find the scheduling algorithms? Anyone can give answer, because scheduling is very hot topic for operating system people. Yes, there are so many scheduling algorithms. Where you find the scheduling algorithm in your machines, where they are working? CPU is a operating system. CPU. Any other answer? Any other option? Kernel. What the kernel is? Okay, go and this is very big question. Anyone can ask where you find the scheduling algorithm. Now, I just discussed what the role of the scheduling. What the role of the scheduling? Just role of the scheduling. If you have many things, simple. If you have many things, let's say many of the student enter inside this room, how we arrange the student in this classroom? That's a simple scheduling algorithm. That may be your first come first serve. As a student entered, we sit at this row, then next row. That may be like this, or round robin. Go that, come here. One cycle is completed, time period completed, then another, and like this. Or so many your own design scheduling may be there. Purpose is amount of resource, amount of number of students, how you arrange m number of student in n number of seats, where m and n are different, or sometime m is very, very large than n. If they are equal, no issue of the scheduling, right? Everyone can get a seat, right? So scheduling of students, scheduling of jobs, scheduling of tasks, right? So task is a smaller unit of job, right? Right? Multi-threading भी आपने operating system में you are doing, studying the multi-threading. You know very well about the process, and you know a process have many number of threads. A smaller unit of process, right? With some specific characteristic, correct? A specific characteristic. So we have similar way, we have jobs. Jobs have a smaller unit, task, right? Tasks that have a small that have required small computing, right? So definitely every job have its own size, and if you want to execute that job or program or process, right, whatever you say, right, if you say program, every program has its size and required some computing of your processor, right? If you evaluate the computing, you say in a million instruction per second, right, or instruction per second, whatever unit you prefer or your machine suggests, right? So that is basically the task, right, process, program. Now there is a term here, that is the offloading. Offloading means bypassing your task to the computing devices, right? And a technology keyword is offloading. So if we want to execute some task, right, then we give this task to someone other. That is called the offloading. If I am not capable to do the exercise, I need help with others, please do it, right? Once you complete it, give the answer back to me, right? So that type of task is called the offloading, right? We offload the task to someone else, right? He do the computation, right? And after computation he returned back the result, and right, the purpose finishes, right? So that is the term offloading, right? So scheduling and offloading. So you have a well defined scheduling because now you are using the facility of fog, right? So you have a scheduling mechanism. The scheduling mechanism means the operating system, because you know any device have a operating system, either your machine, either your mobile phone or any computing device, right? They have the operating system. So if vehicles are at the bottom, right, definitely, because they have the small amount of computing facility, they have a small amount of communication facility. So if they have the computing and communication facility, definitely they have a lightweighted operating system as well, right? If operating system comes into picture, scheduling comes into picture, because vehicles, whatever data it perceive from the environment, right, environment, because the data coming not be an instant data, all data comes instantly, that is a real time application. So data are continuously coming from the environment, right? Let's say data D1 comes at 10 a.m., data D2 comes at 10.5 a.m., data D3 comes at 10.3 a.m., or at the same time so many datas may come. At 10 a.m. you receive 20 type datas, right? So if 20 datas simultaneously you receive, you need scheduling algorithm. You need scheduling algorithm. Who will schedule first? Who will schedule first? Again a decision, right? So there are type of the data you have, right? Type of the data you have, right? So as per the priorities, you do study the priority algorithms, priority scheduling as well. So you can use the priority scheduling algorithms, and accordingly you decide which job has the higher priority, and accordingly you offload that data on your fog devices, right? So two terms we are using, offloading and scheduling. So once we offload the task to the fog, right, or after scheduling algorithms, it is okay. Then another term comes, trust, security, resilience, right? So security, right, because vehicles are the bottom, between vehicles and fog devices there is a channel, right? Definitely now a wireless channel is, right? This is not be a wired channel, this is a wireless channel. And if you study computer network very well, so you know the communication protocol, right? Communication protocol for the wireless networks, right? And you know there is a flaw in every channel, right? Every wireless channel, because that is an open channel. So open channel definitely receive so many types of attack. So you have to ensure the security attack. There is a very important challenge, right? Attacks may be some data modification or something else, but one important channel that is a very specific in this application, that is the sharing of personal information, right? Because here vehicles are communicating with their peers as well as their fog devices, right? So in this communication, so many personal information of the vehicle, right, is shared with their peer devices and the fog devices, right? So we have a challenge how to ensure the privacy of this information, right? Privacy is a very important concern in this application, right? So we have to see, and to achieve this privacy we are using some very good blockchain algorithms, and we are successful in this, right? So these are so many applications, you can find the applications. So in this, I think you clear what exactly the problem is, right? You exactly the problem, because identifying the problem is very important in any domain. If you identify the problem very well, so it is very easy to think about the solution, right? So problem is blockchain in vehicular fog computing. You understand why we use the fog computing, what the vehicular application, why we need this application nowadays, right? And what kind of the issues once we go to achieve this challenge, and why we use the blockchain, right? Why we need the blockchain, so that we can get this solution in a good manner. If you go now, your objective is very clear, we have to achieve that, right? So if you go to achieve that, what the challenges you faces? First challenge, resource allocation. Resource allocation. Resource allocation is what? Because vehicle itself have some smaller computing facility, some more facilities available on the fogs, right? Above that, your clouds are there. So cloud have a very large computing facility, less than that fogs you have, and less than that vehicles you have, correct? So that is a 3-tier architecture in terms of computing. So if vehicle communicated to the fog device, how it know during this offloading, because vehicles receive the task from the environment, right? Let's say any moving vehicle captures the image of any object, right? And he want to take decision on the basis of received image, right? Let's say your moving vehicle pick some picture of accident near to your road, right? Let's say your moving vehicle pick up that picture, and he has to take decision whether he has to stop and assist that one, or he has to move it, right? That is a decision, right? So this application, image application, definitely if you compare this image with your text data, definitely this image processing needs more computing facility, correct? And let's assume the amount of computing with this job is not be sufficient to the vehicle, if you assume, right? So definitely he has to offload this job to your fog device, right? So that he can retrieve the result and take decision, right? So if he want to offload that task to the fog device, but he is not knowing what the computing facility available to that fog node, right? Correct? because unless and until that vehicle is not knowing in real time how much computing facility available to the nearby fog device, right? Let's say he is not be aware about the computing facility and he offload that task. He is not, let's say he is not be updated information, right? And he offload that task. So what happened? Definitely task is not tackled by that device. Your packet loss, task loss, and that vehicle is not able to take decision. Correct? Because vehicle is moving, that is not stationary कि रुक गए जब तक आएगा नहीं decision तब तक हम यही खड़े रहेंगे, because he has to take decision, right, in the moving situation, right? So that's important. So resource allocation is a big challenge, right? We must be knowing the real situation of the computing resources, the amount of computing facility to the nearby devices we have, right? We know it, right? This is the amount of computing facility available to near me. Let's say this camera, if I want forward this job to this computing device, so I must know whether he can tackle this, able to tackle this, or he is not able to do this. If he is able to this, then we can offload. Okay, it's okay, लो कर दो इसको. If he is not be able, so why we should do this, right? So that's the resource allocation is a big challenge. We must know the real time status, the amount of computing facility, because all resources are not be free all time. Once your vehicle move towards a infrastructure fog device, at that time fog device is engaged with doing some other jobs of some other vehicles, correct? Because so many vehicles are, let's say this is a your computing device, fixed infrastructure, and vehicles are continuously moving and they are transmitting the data with this, correct? So maybe once your vehicles come in the premises of this fog device, some other vehicles already forward that data to that device, and the device fog device is now engaged in the computing of the previous job, right? So if you don't have the update information whether the fog device finishes the previous job or itself is in the execution state of that job, or partially executed some job and rest other, so that updated information must be there. That is called the resource allocation problem. Resource allocation problem, that is a big challenge. Second challenge is a path selection. Path selection in the network, you know very well what the path is, right? Correct? So in our scenario, sometime this path may be a single hop, and sometime it is not be a single hop, it may be a multi-hop path, right? Because in some application it is assumed that all the vehicles in the application have same type, right? And if you assume they have similar type of computing facility, that is a one scenario, but that is not be a very practical. You know, on your roads n number of vehicle types, right? Some two-wheelers, some four-wheelers, then your trucks, your buses, and so many other, right? And if you see the amount of power, that you know some big vehicles have much more power as compared to a smaller vehicle, right? So assuming this assumption that all the vehicles have similar computing is actually not be a valid assumption. In real life we have different types of the vehicle, so what we assume that different types of computing power to the different vehicles, right? So some vehicles that have less computing power they can assume as a normal vehicles, right? Some vehicle that have some more power, computing power as compared to the normal vehicle and less than the fog, they fog node of the fixed infrastructure installed on the fixed infrastructure, right? So less than that of, so in between of the normal vehicle and the fog computing device. So those vehicles, right, those vehicles may sometime considered as a fog node as well. So you can say fog nodes may be static, may be dynamic as well, right? In the static scenario, your fog device installed on the side of road infrastructure. In the dynamic scenario, if you have some vehicle that is a sufficient computing, so that can also be considered as a fog node, because he has a capability to facilitate some smaller vehicle as well. If some car is there that need help with the truck, so definitely he is capable to helping them. और ये आप usual scenario में देखते हैं, बहुत बार आप रोड पे जाते हैं and then you see some car is crashed, then you see a truck that is towing that car, right? He has a capability to facilitate that, right? So in the fundamental sense, you assume fog nodes are computing device, a static computing device installed on the side of the network, side of the road, and some computing devices that is a dynamic, some vehicle can also be treated as the fog device, right? So if some vehicles are considered as a fog device, some vehicles are considered as a fog device, so your fixed fog devices and movable fog devices, right? Movable fog devices. So if movable fog devices, so all time it is not possible to a single hop communication with their peers. एक fixed है, जैसे ये लगा हुआ, that is a fixed computing. If sometime I am here, I can coordinate with this peer. I am also be the fog device, he is also be the fog device. It is able, but if I move at the end of this room, it may possible he is not able to communicate. I am not able to communicate with our peer, right? So in that case, single hop communication is not be sufficient one, correct? So we need multi-hop communication, right? Multi-hop communication. I tried to fetch some other fog device, some other vehicle, dynamic vehicle as a fog device, so that using that vehicle I can coordinate with this one. That is called the multi-hop communication. Multi-hop communication, right? So if it is possible, it's okay, right? So in the multi-hop, and this is usual, right? Single hop communication is not be sufficient one. So if multi-hop communication, then you have a issue of the path selection. जैसे ही multi-hop आया, so there may be so many. He is the guy using that, we can coordinate. Some other student using that, we can coordinate which path I have to select it, right? Your path selection algorithms comes into picture. Your path selection algorithms comes into picture, right? Immediately, once you have so many options, right? In the network, you studied very well connection oriented and connectionless protocols, right? Connection oriented, connectionless protocols, right? So you can use some protocol, and using the protocols you can decide it. So path selection is another big issue in this environment, in this application. Now let's say you know the real-time application of the real-time computing, know the computing facility of the resources. Now you decided the path selection algorithm. Then your job is over, your setup is ready. Your setup is ready, you decided the path. Whatever task you receive, we decided the algorithm. Using this, we can coordinate this communication setup, computing we know. Then we can offload the task, no problem. Offload the task, he will do the computation, and using some path, I can retrieve our data. But in this process, this is a process, in this process, we may face security issues, because I am sharing some data with our peers, and with this device, and the channel is a open channel, mostly wireless channel, right? Wireless channel also always suffers security issues. And in this application, although so many types of attacks are possible, but privacy is much desired. That is a very common, right? We have to ensure, because sometime we want to share some, because that is a mandatory to share some information, personal information. Vehicles need, it is required that vehicle need to share the personal information. आप अपनी बहुत बार होता है ना, let's say you have to share your Aadhaar number, that is a mandatory, right? So some personal information in this setup, it is needed that vehicle has to share, right? If you share, the same time you have a challenge to provide the security with that type of data sharing, right? अगर आपका आधार नंबर कहीं गलत जगह चला जाएगा, then you know kind of difficulty you faces, correct. So that's the application, because if you go in the passport office or somewhere else, then they insist you, please give your Aadhaar card, otherwise your formalities would not be completed. So it is required one, you have to share your personal information, but at the same time you have to provide the security. And sometime they says that no, don't worry, we secure your data, right? That is basically the privacy issues, right? Here in the privacy preservation, there are so many types of the privacy, especially in this application, location privacy, because in this scenario every time vehicle need to share their locations, right? So if someone knows the current location of some vehicle, then he can do so many malfunctioning. ठीक है ना, बहुत बार आप देखें क्राइम होता है, they try to get the exact location so they can plan accordingly where you are, right? So that is the location. So in the vehicular application, location privacy is a big challenge. No one want to share their current location where he is, right? Correct? So location privacy is a very big challenge in this. So three important challenges, so many other challenges, but three important challenges in this application scenario, right? So now we start some issues of the blockchains, how the blockchain come into picture, because your talk is regarding the blockchain technology. So you know, blockchain is just provide as a security solution, right? So using this technique you can secure your data, right? So in this blockchain you have basically some data structures, right? You have to maintain some distributed ledgers and some other. So we see how we use this in this our case. Just a minute. So let's say this scenario. This is overall picture. So what this picture? Your vehicles. You see your vehicles, right? These are your vehicles. These are your computing device, and these are base stations. So in this specific example, what we are considering, because we are focusing on the single hop communication and we are using the 5G technology, your cellular technology, right, in this application, because there are different communication protocols, right? So in this example scenario we are using the cellular technology, right, 5G technology. In cellular technology, if you know how your mobile communicate, right, so you know the overall board है क्या, मार्कर देंगे क्या? So your overall scenario means, let's say your university, right? Let's say if you assume this university, right, then 10 kilometer of this university may consider as a cell, because Kanpur, if you consider as a Kanpur is a district, right? In this district there may be n number of cells, right? One cell representing one locality of 10 kilometer, let's assume, another cell representing another locality of 10 kilometer. Like this way the mobile communication happens, right? So if you are a user, once you make your call is forwarded to the base station of your cell first, correct? Correct. So that is this type of structure assume. Here they assume a single cell, this is overall cell, right? Because we are considering the cellular technology here. So this is a single cell, right? In this cell one base station is installed, right? Base station may be assumed like your fog device, let's assume, because fog is a central entity, right? Here we are discussing the distributed approach. So this base station may be treated as a fog, right? Means higher computing as compared to these. So base is considered as a cloud, right? Sorry. So these are the fog devices, right? So this is a overall cell, right? So what happens as the vehicles communicating, these are some fog devices. This is one type of fog, another type of fog, like this. So and some other vehicles, if you consider the heterogeneous environment, so some other vehicle among these may also considered as the fog devices. But in this specific example, all the vehicles are considered as a homogeneous, right? So they are not considering as the fog. Only these static devices are considered as the fog. So you know the communication vehicles, once they receive the task, they offload the task to the fog, and sometime this need to communicate with the central entity because they are considering the 5G cellular environment, right? So in this, right, so simple data sharing is shown in this diagram, right? Simple data showing, right? So vehicle offload the task to the fog devices after doing computation, they return the result back. If they need further assistance, these devices sometimes are not be sufficient to handle some application, they need the assistance with the cloud as well, central entity, right? In such data sharing, how they use the blockchain, because this channel is open, they need to secure this communication. So using this secure communication, they use the blockchain, right? So they maintain a ledger. Whatever task the vehicle generate, so corresponding to that task, one entity, ledger, you know very well what the ledger is, right? Ledger, in that account people knows ledger very well, right? Make the entry corresponding to every transaction, credit, debit, right? One side credit, one side debit, right? That is called the ledger, right? Who will come, who will go, right? Similar way in the blockchain, every task is represented as a transaction. Every task is represented as a transaction. And in your database system, you know very well what the transaction is. If you go and see your course, you identify very well what the transaction is. Single logical, one line definition, single logical unit of work is defined as a transaction. Every transaction has certain characteristic, right? Atomicity, durability, consistency, isolations, right? You know very well, correct? So every task, if vehicle finds to offload on some fog devices, that task is considered as a transaction, corresponding to that transaction, that is a unit of job, right? That transaction is recorded in the ledger, blockchain ledger, right? Task come, right? Task completed, that is a credit debit. If someone comes, recorded in the ledger, task completed, remove from the ledger, right? Now there is some so many information corresponding to this task maintained in this ledger as well, but this is very fundamental, right? Very fundamental, exactly what the blockchain ledger is. So this is as similar to other ledger. We record the transaction in this ledger and we also store some other relevant information corresponding to that task, right? These are some applications of the blockchain you find as well. मैं इनको leave कर दे रहा. This is how blockchain works. So I hope you understand in last 2 days how exactly the blockchain works. So a simple abstract level diagram. So transaction is requested, blockchain transaction is created, yes, definitely corresponding to that transaction, blockchain data is created, blockchain sent to every node in the network. Yes, that is the heart of the blockchain technology, because if some transaction is generated in the ledger, right, so that information is coordinated with all the peers as well, right? If I receive something, if I receive this, then you know all that I receive something, right? That's the heart of the blockchain technology, right? If some entry is made in the blockchain, every peer in the system is aware about that, right? That this entry comes in the system, enters in the system. Once it leaves, everyone knows. So how everyone knows someone comes and how it knows that someone left? By looking the entries in the ledger, because a central ledger, blockchain ledger is maintained, right? So everyone, every vehicle have some updated information of the ledger, right? You have the copy of the ledger, you have the copy of the ledger, all have the copy of the ledger, right? So once you want to know, right, who is in this room, so it's not be like that, yes, I am seeing, this is not, just I have the copy, I see it in the ledger, yes, this ID is present, because every student has the roll number. So similar to that, if ID is present, that means he is there. So that is a fast way mechanism, right? So everyone have the copy of the ledger, right? By seeing that ledger, they identify who is present in this room, who is not present in this room, right? So that's the objective. So using this objective, they solve so many applications, and this blockchain is important here, because in this application, vehicles are sharing their data with their peer vehicles, as well as with their fog nodes, correct? So if all are in the cooperated environment, vehicle with their peers as well as with the fog devices, all are in the cooperated environment, right? So everyone must know the activity of others so that their cooperation is up to the high level, right? Because overall cooperation as much as better, because application is very, very sensitive. Lacking of a fraction of second collapse so many lives, right? So if cooperation up to the higher level, is desired here, right? Correct? So that's important, right? So, and that's why we are using with the blockchain. Cooperation is there, because heart of the blockchain is cooperation is very, very high level. If someone make update, the update forwarded to all those, correct? So that is this. So simple. So node receive a reward for the proof of work, and block is added to this, right? So if it is worthy to add that node in the ledger, right? If some node enter and it is worthy to add that node in the ledger, means some mechanism who allowed to enter, it's okay, because something you need to verify. If some student want to enter this in this room, that is as a ledger, you have to verify whether this student belongs to this class or some other class, why he want to enter here, right? So some mechanism, some algorithms you have, using those algorithm you authenticate that this is okay, this is a student belongs to this class and relevant student, we can allow it. So similar way nodes receive a reward for the work. So that is called the reward mechanism. Reward means, now because if someone sit here and attend the lecture, I think definitely he has able to enhance their knowledge. So that is a kind of the reward, right? So if transaction is allowed to make an entry in the ledger, that transaction gets a reward, and then block is added in the ledger as a reward. Then your transaction is called as a completed, right? So this is simple mechanism, because we have to need this, that's why we discuss it. So इसको मैं leave कर देता हूँ, because this is all about the, yes. I know very well because you are, as a student, you all are doing some project in the machine learning, right? Today a very big term for you, and I know very well what you are doing in that project, right? Just taking a data set. In your Python you have so many libraries, right? Use your libraries and get your output. So easy job, right? So if you compare that with this one, definitely you face some issues, but that is not be a all time solution. You have n number of the problems in your real world, and we are providing the solution to those problems as an computer scientist, computer engineers, right? If you get placement in some companies, it's not your choice, sir, I know only data science, right? That's why you are studying so many subjects in your course curriculum, right? You study operating system, you study database system, you study computer network, distributed technology, distributed systems, and so many systems, right? Computer architectures, digital systems, so many systems, because you are, so that you are capable to handle such problems, right? So this is a kind of application problem where you can observe your knowledge, correct? What you study the operating system, in this problem you identify everywhere. If you want to identify the, if you are an expert of operating system, and because this is a big module, this is a big module, big project, right? N number of the peoples are working in this big project. Someone is a specialist in operating system, someone is a specialist in machine learning, someone is a specialist in the blockchain, someone is a specialist in the communication system. Then you can, at the end, you have a successful project, correct? So try to connect with the different applications and sub applications in this same project, right? So I hope you, with the same interest, you are showing your interest in this way. So in the blockchain, we are seeing the application of blockchain in this domain. So we talk about the ledger, right? Because every blockchain system maintains a ledger. In this ledger there are different types of the blocks, right? Because every transaction is considered as a block, right? Different types of blocks in that ledger as well, right? So in this work, because this is user defined data structures, this is user defined data structure, right? Some fixed block structure, some fixed type of block suggested by the initial development of blockchain. Beyond that, some user defined blocks may be suggested by the developer as per the requirement of application. In this work, we are considering three types of the blocks. Blocks are simple transactions. The details of transactions are collected in a block. Block is just a data structure, right? Block is just kind of data structure. So the name of the block in this work they considered as a resource block, task start block, and task end block. So resource block, the type of resource block gathered the information about the resources. So in this application, fog devices are considered as the resource. So what kind of information these resource block have? They have the IDs of the fogs, right? Near about the fog, because fogs are also be connected with each other, right? So once a resource block created in the ledger. So what the information that resource block contain? That contain the fog IDs. Fog IDs within that cells, because this system considers 5G cellular network. 5G cellular network have a cell partition into multiple cells, right? Every cell has a base station. Within that cell means within the premises of the base stations, so many fog devices are there, right? So whatever fog devices within the premises of the base station, the IDs corresponding to those fog devices are maintained in this data structure resource block, right? Name is resource block. Capacity of the fog device, computing power of that fog device, right? So fog ID this, computing power is this. Concurrency model. So every resource block have the concurrency model. What this concurrency model is? Because fog device may receive n number of the requests, n number of the tasks to process at the same time. Concurrent task, right? Concurrency control you study in the database system. If n number of transactions you have serial schedules, you have serializability model. So many concurrency models you study very well, right? So if n number of the request a fog device receive, so how it maintain the concurrency so that execution of all the tasks happens, right? So the algorithm, so what the concurrency model you consider, because this is your choice, right? You can design some good concurrency model as per the requirement of application. So whatever concurrency model, how the algorithm gets executed, what the requirement of the algorithms, that is also be considered as an input information in this resource block, right? So in the blockchain module, these type of information gets collected about the fog nodes. Then task start block, another data structure created when CV offload a task. You know offloading. So once some vehicle perceive the data from the environment, like I give an example, once some moving vehicle pick up a image, right, of any accident, right? So that is considered as a task. Sometime, because every vehicle have a small amount of computation, sometime task is completed locally on that vehicle itself, sometime it is not feasible by that vehicle to compute, they need assistance of fog device, right? So if created when CV offload a task, so if it is not feasible by the vehicle to perform computation with that job, with that task, he has to take decision to offload this task to the fog device, right? So once he decided, that means task start block data structure maintained, means all the information about that task is created and stored in this block. जैसे प्रोसेस आपने पढ़ा ना ऑपरेटिंग सिस्टम में, once process is created, so many information about the process is created in the process control block of that process. आपने बहुत अच्छे से पढ़ रखा है PCB of that process, right? You know process IDs, process life state, process states, and so many other similar way, very similar. Once vehicle decided to offload that task, a data structure is maintained, right? That is called the task start block, stores information about the task, newly created task, right? Once task completed, how task completed? Vehicle offload the task to the fog, fog doing computation by itself, or sometime it take help with their peer fog devices, and then in that system, coordinated system, after doing the computing, return the result back to the vehicle. Correct? That is the offloading process. That is the offloading process, right? So one task is offloaded, process is generated till the process is completed, right? So during their execution, during the process gets executed, life cycle of the process, the same here. The life cycle, process is created, task is created, information is stored in this task start block. Once process is completed, that information means, right, task end block, mark task completed. So these three are basic information they maintain. So resource block, these are important fields. You see, resource block, because we are talking about the blockchain, right? So blockchain have create the node, every node base every transaction is right. So transaction have the resource block. So resource block, you see block header, previous block header, right, previous block header, and this description is hash value of the previous block. This is very important, hash value, right? You know hashing techniques in your cryptography, right? So from that, blockchain uses that concept to maintain the security. Hash algorithms are much secure algorithm, because hash functions, this is not be your data structure hash, this is cryptographic hash, and cryptographic hash has a very beautiful property that they are one-way functions, right? If you have x, it as an input, you perform the hash, you get the y. But the same hash function, if you apply on the y, you are unable to retrieve the x. Due to that reason, we are very much rely on the hashing techniques in the security domain. So blockchain also uses the same concept. So what the resource block maintain, because you see resource block have the IDs of the fog IDs and so many other, all these informations, whatever you see in the last slide, you see resource block have the fog IDs, capacities, and the model, algorithm, computing power, and the IDs. So how these information get secured, right? So this security is provided in this blockchain by well-defined hash algorithms. So the resource block contain this information, but it have some header information in, जैसे आपने network में पढ़ते हैं ना, packet header and data. So header also have some subfields, right? Similar way, this resource block have some header information, have some data information. Header information, previous block header, because blockchain है, so every block is connected with the other block. That's why it is called blockchain. So resource block connected with the previous block, right? And this way the chain is maintained. So how this connection is maintained, hash value of the previous block, this another header information, time stamp. Once this block is created, current block has value of the current block. So hash of the previous, hash of the current. So perfectly secure, right? And then these are some data values, data fields, right? Fog node ID set, ID, what we study, see there, IDs of the fog node location, locations of the fog node, you see computational capability and the model, algorithm. यही होगा भाई, fog node पे एक algorithm चल रही है, that is the algorithm to managing the inputs in terms of the task, right? So all these are information maintained in a data structure resource block. So I think these are sufficient enough. Task start block, once task is started, So task start block is created and added in the ledger. So similar way, these are the informations regarding the task. So hash value of the previous timestamp, this header information nearly same, and then related to the task information. You see ID of the task is preserved, data size of the task, computational requirement of the task, timestamp of the task, ID of the host fog node. This is important, right? And one thing remember, these are user defined data structures, right? Right? These are some listed fields. If as per the demand of application, yahi par aapka kaam hai, this is your work, computer scientist work. If some change in the application, right? If some application requirement is this one, now some other application need, you have, no, this, there is some issue in this, you have to update this, then you can add so many fields as per the requirement and go ahead. So you have to identify the requirement accordingly. You have to update in your data structures, right? These are data structures, right? Any data structure you can use to manage these informations, right? So do you see host ID of the host fog node, because tasks generated by a vehicle need to be offloaded on the fog device. So on which fog node that task is offloaded, right? So that is decided by this ID of the host fog ID. Once a task is offloaded to a particular fog node, so ID of that fog node is stored in this field, task start block, correct? So this way this ID is stored. So these once task is completed, you remove those, right? Like this is informations. Now in blockchain, you know what about the consensus nodes, right? In this application, consensus nodes, basically node in your block, right? Consensus nodes are called simple nodes in your blockchain, right? So nodes in the blockchain are created by the client vehicle and zone heads only, right? Means because three types of the blocks you consider: resource block, task start block, task end block. So once task is offloaded, then task block is generated. So task block is generated by your vehicles, right? And recorded in the ledger. And similar way, the higher entity, zone head, base station. Zone head is the base station, right? So zone head maintains the resource block, right? Resource block. So that's why we are showing that consensus node, right, maintains the and verify the block. Only two has the capability to do this, right? Generate the consensus node, right? So how the blocks are generated? So when a task is offloaded, new block is generated. First block is in each ledger is a resource block created by the zone head, that is a default block. Default block, okay? Default block. So first block in the blockchain is created by your base station, right? And then because initialization, that is the initialization. So initialization is done by the head, and then your application is start as tasks are incoming. Similar tasks, if the requirement is to offload, vehicle generate the blocks and appended in the ledger. That's the operation. Every new block references the hash of the previous due to the security, right? So that information get not be modified, right? That's the use of the algorithm. And then consensus mechanism. Consensus mechanism means the algorithm in the blockchain, using that they verify whether we have to add, we give the space to the new node in the chain, or we have not to give the space, right? So accordingly to the what algorithm defined, accordingly we decide. There are some right? How we updates in the blockchain, the maintenance of the blockchain, new blocks are appended sequentially, each linked via cryptographic hash, right? So they appended sequentially, standard characteristic of the blockchain. Read-only structure ensures data immutability and integrity, right? So read right? Reading capability, read only, right? So anyone can read it. If he make the update, then the same update is reflected everywhere in their cooperative environment. And this distributed so that we generate the reliable traceability of all offloading events. And this is a distributed storage. All consistent node jointly stores a replicated copy of the blockchain. That's why I am saying replicated copy. Every entity means every vehicles and fog have the replicated copies, so that they can check once their requirement is there, whether it is peer device or somewhere else, they can verify it. चलिए थोड़ा सा So how this operation exactly perform? So firstly, when a task is generated to offload, so he has to check, the vehicle has to check the ledger, right? Ledger means blockchain ledger, right? So one new task is generated, CV consult the blockchain ledger, right? Reads, because if already the similar events, similar recorded block, that means a redundancy is there, so it avoids that. Otherwise if it's a new task, right, कभी कभी होता है ना similar request आपके पास 2 बार entry होगी due to the malfunctioning of your hardware or software, right? So that redundancy must be avoided. If it is okay, new job is there, new task is there, so new entry is created, so it is allowed. Reads resource blocks to find nearest fog IDs and resource information. So we see the structure, data structure of resource block, and we see in this resource block have the data field like the fog IDs, computing capacity of the fog node, we store that, right? So using that information, what the vehicle is needing to doing, he has to check the resource block available in the ledger, right? Using the resource block, he identify that what the computing facility available on the fog node, what are the fog nodes available in our premises, right? Accordingly he has to take decision, because n number of the fog nodes available to the vehicle, right? So he has to decide on which of the fog node I have to offload, right? So once it looked at the resource block, identified the available fog IDs, among those as per the algorithm he decide on which fog node he has to offload. Then read task start and task end blocks to identify currently executing task. So once it decide that I have to offload this task to this fog node, right, then he has to again check the task start and task end blocks from the ledger, because it may possible on the same fog node so many tasks are already in execution, right? So he has to need to recognize what are the tasks in the are already be in recognition, because sometime he has to cooperate with the computing, right? So he must know such type of information, and then provide real-time visibility before making the offload. So if all these checking from the blockchain ledger, then if all things are settled down, then it take the decision, now it's okay, things are okay, then I offload this task, correct? Then decision making. Now if it take the decision, now things are okay, so he has to take the decision, right? Things are okay, but he has to take decision, so that is called the decision making. So based on the ledger data, the vehicle decide offload to the fog node or execute the locally. Then things are okay, then he has to check whether it is feasible to execute this task on my end or we need the assistance. So that decision algorithm. So decision algorithm use that data inputs, and according to the input they decide. So the algorithms जैसे ही आया decision आया, then means algorithm आया, और algorithms, that is your end. Computer scientists design well algorithms, efficient algorithms, right? तो अब algorithms आ गया तो हर जगह एक novelty आ गई. Now problem open, you can write your solution, right? All of you write your solution, and we always happy if someone writing is very good solution. Good solution means efficient solution in terms of time, in terms of space, right? So in this work they uses a very good algorithm that is called the deep CNN network, that they name as a deep Q network. They name their algorithm as a deep Q network. Basically this is a deep CNN model. Optimize trade-off between self-latency and global resource fairness. So with this algorithm, this is an algorithm to decide whether we have to offload or not to offload, right? If we decide we have to offload this, right? Let's say decide it's not be possible to execute this task on local, definitely we have to offload. Once it decides to offload, in the offloading, what our objective is? So objective is optimize trade-off between self-latency and global resource fairness. The objective is to minimize the latency. Task offloaded, latency means just simple words, you can assume the time taken once you offload the task and once you receive the output result, right? So in between of that, because this is a complex scenario, right? This is a vehicle, right? Once this vehicle to this fog 1 offload this task, so on this the fog layer, this is your fog layer, simple fog layer, so many fog nodes, right? And all these may be something, so many fog nodes, right? So time taken, right? Let's say it forward this and then this forward, that may be less time. If it further this chain gets longer, time definitely be high, right? So how objective in this offloading, offload to karna hai, that is decided, right? But once we upload, our objective in this application, objective is latency minimum ho, right? And resource fairness ho. Resource fairness is what? It not be the situation that particular fog node is overloaded. Because it may possible, let's say this is a movable vehicle, right? Vehicle is moving, right? Let's say this vehicle offload this task to this fog node, and this fog node is very near to this vehicle, right? So during this movement, because the situation is very dynamic, this vehicle perceives the task from the environment continuously. This is not discrete, this is continuous task gathering, right? It just immediately forwarding the task to this fog node. So the situation is that although there are so many fog node available in the fog layer, but due to the distance of this vehicle with this fog, it may possible that this vehicle offload many of the tasks to only to this fog node. And what happened? Situation is that this fog node says no, I am not capable to handling such request, right? So that's the reason. So that's called the fairness. So what? Offloading that must be fair, means the load must be distributed among available fog node so that we can utilize better the resources of these fogs, right? That's why that is called the trade-off. Latency chahiye, right? Because you know very well, if this vehicle offload the task to this vehicle and retrieve the result back, definitely latency is low as compared if this vehicle offload the task to this one. सीधी सी बात है. But failure से भी बचाना है. So we have the objective in this method is we have to manage this trade-off very well. ठीक? Resources must not be overloaded, latency must be minimum. That's why they uses स्पेसिफिक मॉडल. टाइम बताते जाएगा सर, क्योंकि अगला भी शायद कुछ आप डिस्कशन करता ना 12 to 1 अदर टॉपिक में था ना कुछ, इसी को कंटिन्यू कर जैसे बताइएगा. Right? So that is your objective. That is your objective. Right? Right? In this algorithm, objective is clear. Then this is task offloading. Simple. We already discussed this. In this model, they are considering a single hop. In the very beginning, I talk about this offloading may be single hop, may be multi hop. In this problem, they are considering only single hop. They assume that vehicle available within a single hop distance with the fog node. And then task completion, task and block, ये सारी डिस्कस हो गए. Just a minute. See this. See this. Just because due to time constraint, just explain the overall picture. What happens in this, right? What happens in this, you see, these are vehicles, this layer, and this is a blockchain, right? This is the blockchain, right? So, what we discussed previously, देंगे कुछ. चलिए बैठे रहिए, छोड़ दीजिए. So what we are discussing previously, this is a cell type of structure. Let's assume this is a standard cell structure and this is your base station. This is your base station and so many vehicles, right? So many vehicles are there, right? Between this, right? Between this you have some fog layer. This is a fog layer where fog devices are available, right? So what happens here, these are the vehicles, right? And on these fog devices, let's say these are fog devices, simple fog devices on this layer, right? So what in this model they uses are, because this deep Q learning model, so what they doing, they trained the model, machine learning, right? They trained the model. So with the available information in the blocks, they trained the model locally. This is a fog node. This is, समझते जाइएगा, this is the fog node, correct? This is the fog node, correct? So fog nodes are receiving the data from vehicles. Fog nodes are receiving the task, because on this vehicle algorithm is running, right? Algorithm is running to decide whether we need to offload the task or not. Let's say algorithm decide yes, we have to task offloading. So when is offload the task, this vehicle receive the data and that is called the training. So this continuously receive the data. With that available data, we use the training model. Data आ गया, उससे एक हमने यहाँ पर मॉडल ट्रेन किया with the available data, right? So that once we trained a good model, machine learning model, after training with this data, once we retrieve this trained model, so for the new task we can take better decision, because objective, remember the objective in this process is what? Manage the trade-off between latency and resource utilization. So why we train the model? So that we can optimize this trade-off, right? Once we get the good trained model, then we can decide better this trade-off for the new task, right? Whether we have to offload here or here as per the outcome of the trained model. So on every fog node we do the training, and this training is a federated learning training model. There is an approach in the machine learning called the federated learning. Like machine learning, there is a federated learning, and in the federated learning somehow different. What the difference is? Simple difference. If you perform job very well, I just give you a reward. If you not perform job well, I give the punishment, right? The similar way, if model learns well in the multiple iteration, because learning is in multiple iteration. So if we execute the first iteration and I identify that model is okay means very close to the actual value, error is less, that means we identify model is good, so we give some reward. So that why the rewards are given so that you encourage next time you are doing some more better. That's why rewards are given. On the same principle this learning is basis. So if in the first iteration, if we identify this is an actual output, this is actual output, right? This is actual, and this is your outcome of process, right? And you find this is error, right? So it's okay. In the first phase, I assume it is okay, right? So we give some reward. Let's say some reward is given, right? So you encourage in the next round so that next time your result is maybe like this, and you are somehow very close to the actual one, right? But in the second round, if in the second iteration, if I identify that no, your result is not closer, now it is far to the previous one, then we give the punishment, some amount of punishment, right? So that you improve, right? So reward encourages, punishment chance to improve, right? The same manner is this model, federated learning model. So what they are giving on every node, every fog node, training is there. Once we get this training, the local training, and then further training is performed on this base station, right? So on the base station, the final training is there. So final model, as you see in this diagram, this final model is executed on the base station side. So you see this is information. So this is called the local federated learning performed on the fog devices, right? Local training, right? So this is local training and this is the global training. And in this training, they use the CNN model, deep CNN model, right? So CNN model objective, you know, in the CNN model, you update the weights. In the multiple iteration, your objective is updating the weights corresponding to the different links, right? वही इन्होंने किया है. Simple. These are the parameters they are evaluated. These are the parameter to achieve the same objective, to manage the trade-off between the latency and the resource utilization. उसको करते हुए इन्होंने इसको trained कर दिया, right? So they have the good trained model at the base station, and then they give that trained model back to the fog node, right? So overall trained model, then overall trained model further given back to the fog devices. See the good advantages. Local training, then global training. After global training, they prepare a final model, right? Right? जैसे आप सबने problem solve करते हैं ना, फिर instructor आपकी problem check करता है. After doing so many correction, okay, he said इस exam paper में आप सब लोग लिखते हैं, right? And he evaluator give this, no, this is the final right option, right? So the similar way, so the final trained model prepared by the base station, and then base station give the final model to this. So now अब क्या हुआ? You get the correct answer for that problem. So next time in your life, if you faces the same problem, you know this is the right option. So next time, once the fog devices receive that task, use that global model locally. To take their decisions. So latency is minimized. इनके पास global model आ गया. So once they receive the global model, so next time once they receive the task, they can decide the locally, and then latency minimize, right? That's the learning algorithms utilized here. So this is overall picture. You see, communication, operating system, blockchain, machine learning, right? जो सारा कुछ आप पढ़ते हैं, in the whole application you find, right? This is simple algorithmic steps. So इसको छोड़ देते हैं. These are some parameters, mathematical parameters they evaluated, because there are latency they evaluate. So there are two types of latencies. I just brief. Two types of latencies. One is the communication latency and computation, means time taken in the communication and time taken in computation. Means if some task is offloaded to the fog node, so that is called the communication. From this to this, if task is offloaded, some time is needed, right? That is called the communication time. So how they evaluate the communication time? The size of the task, Si is basically represent the size of the task, and this R communication is basically the radius, distance, right? उसको उन्होंने communication latency निकाला है, right? Theta is representing the fog node and Vi is the vehicle, ith vehicle that offload the task. So this is communication, standard mathematics they use. For the communication people, they know very well, right? So I communication latency they nikala, and then evaluate the computation latency. This is called the computation. Once task is available to the fog node, so how they compute the time in the computation. So this is the size of the task. This is the size of the task, and this is the available computing power. Means this is basically the computation requirement of the task, and this is the total computation available on the fog. This is the total computation available on the fog, and this is the requirement of the task in terms of computation, number of instructions per second. So using this they compute the computation. So if they add the both, then they can say overall time. Computation plus communication time, that is the overall time. So overall latency. So वो उन्होंने निकाल लिया, and then they find the rewards. How they mathematical उन्हें function बनाया. They design a mathematical function to define the rewards. कितना rewards देना है, right? So उसके लिए mathematical वो आप भी अपना बना सकते हैं. That is, there is such perspective, right? You can design your mathematical model. In this mathematical model, what the parameter they considered? Li, basically the computation latency, and this theta I is basically the computation of the fog node. So using these, alpha, beta are constant variables, constant terms. Using this, they define a mathematical function to decide the amount of reward we have to give, right? Amount of the. So this, and then now they decide the mathematical function. After deciding the mathematical function, they design an optimization problem, right? So if you study an optimization theory, right? So there is a course, right? Optimization theory, right? Optimization methods. So if we have some function, how we optimize that function under defined constraints. Simple. If you have some function like this function, this is your function, mathematical function of two variables. आपने single variable का function पढ़ रखा, y is equal to fx. That is a single variable function. X is your independent variable and y is your dependent variable. Single variable. Now if we write z is equal to fx y, two variable function. So this is a two variable mathematical function, right? So now we optimize this two variable mathematical function under defined constraints, right? Under defined constraint होगा ना कुछ constraint होगा. Every system has a constraint. So what we are constraint imposing, so we under certain such that xi is whether he has to decide the task need to be offloaded or not. 0 means not offloading decision and 1 means offloading decision. So whatever constraint, under this constraint it doing this, और ये इन्होंने किया हुआ, ठीक? So they evaluate so many parameters, loss parameter, because they execute the machine learning algorithm, so they compute the losses and compare with the other good algorithms, and they find the good achievement in the loss, right? So these are some parameters. ये आपके मतलब का नहीं है. एक और स्लाइड होगी, एक और स्लाइड चला दीजिए, जस्ट अ मिनट, एक स्लाइड और होगी साहब, एक स्लाइड और थी साहब, एक secure. That's it. The role of blockchain is limited in this application only to making the security. That's it. Otherwise, this is an work of the fog computing. Blockchain only plays the role to maintain this data secure. अभी आपने बताया, once task is offloaded, task block is generated, right? Task is offloaded, task block is generated, and task block is secured, right? Task block is secured, correct? So, and that thing is maintained as per the blockchain structure, correct? Because once any updation is there, that must be reflected to other to get the real-time information. Vehicles and fogs are considered because they are only capable to handle this. So blockchain is just for the security purpose. That's it. So, और कोई रोल नहीं है. नहीं, fog is nothing else. Fog is just a abstraction layer. Simple जो आप पहले काम करते थे cloud से, that work is now done by your fog. Objective is clear. You have to reduce the latency as well as optimize the resources, because so many issues with the cloud. Cloud is a centralized system. Cloud is a centralized system, right? Fog is a distributed system, right? So whatever you faces with the cloud, to overcome that you have another model of computing, that is fog computing. Computing applied in vehicular domain, that's why it is vehicular fog computing. Tasks need to be offloaded, so whatever information is offloaded, that must be in secure way. Result retrieve in the secured way. For that purpose we are using the blockchain, right? We have discussed the concurrency model, because once it offloaded, multiple tasks received on the fog node at the same time, right? So that may affect the execution of already executed task on the fog node. हो सकता है ना? So then you have to optimize that the new task once offloaded, it not be impact the latency of the previous task. For that purpose we have to optimize the latency as well as resources of the fog node. So this is overall picture. तेज थोड़ा बोलिए प्लीज. पेनल्टी होगी तो कैसे वर्क करेगा? Penalty and reward, these are iterative sense, right? Let's say if some rewards evaluated, right? This is a mathematical function to optimize both the parameters, right? In that parameter, if you solve that, so you find what the result in the iteration. ठीक है? अगर आपको याद होगा डेटा माइनिंग क्या आपने पढ़ी है, and in the data mining you two algorithm, one is a bagging approach and other one is a boosting approach. Bagging and boosting, if you remember very well, bagging and boosting in the data mining, if you remember, anyone recall? Bagging and boosting, the same approaches. Yes, you just see the bagging and boosting, the fundamental of this federated learning is very there. In the multiple iteration, if you achieve something, then in next iteration we increase the weights, because we train the deep learning model. In the training of the deep learning model or any CNN network, you update the weight, correct? So that update the weight is basically the kind of reward. ठीक है? अगर update होगा या may not be the same, इसमें नेगेटिव नहीं है उसमें, ठीक, बिकॉज द वैल्यूज ऑफ द वेट फ्रॉम 0 to 1 either remain same or towards the 1, right? If remain same, that is you say no improvement. Objective is always improve closer towards 1, right? वही है, देखो उसी डिटेल में थोड़ा सा ज्यादा जाना पड़ेगा, टाइम अलाउ नहीं कर रहा. Now place what the place just how much time? Just 30 minutes, 45 minutes. Just see place what the work we discussed, that works, the last work, blockchain in the fog computing. I give the reference in that slide as well. That is published in this 25, this year 25, right? That work is published by some foreign authors in this year 2025. Means whatever modeling is given, that is given by some foreign researcher in 25. This is my work. I think this is published in the 2021 or 2022. This is my model. How exactly? So we are not using the blockchain here. We are not using the blockchain in this work. We are simple objective with the optimization of latency as well as some other parameter in simple task offloading module, right? So we just, because this is a discussion. So this is my model, future mobility and imminent computation aware task offloading approach in vacuolar fog computing environment. So important चीजें मैं इसमें आपको बता देता हूँ. So in this work, what we are considering, focusing to handle the mobility issues and the computation requirement, computation available on the fog devices. Because one big problem with this system is we are not knowing the available computation on the fog nodes in real time, right? We are offloading the task on the fog, decided, right? But we are unable, it is very difficult to know what the available computation on the fog in real time. Real time का मतलब instant, every instant. If you want to know in every cycle, because updates are in every iteration, so it is very difficult, right? Let's say 100 instructions are the total capacity, 100 instruction execution is the capacity of the fog node. Let's say 2 tasks are running on the fog node. So every task, the running task definitely have their own requirement. So as per the requirement, they consume some computation of that fog node. Let's say new task is waiting for getting the updation, means to execute on that fog node, but he is unable to find, if he is not be exactly knowing this is the amount of available resource available on the fog node, how it can offload that task on the marker है ना, just एक रब करने का दीजिए, थोड़ा रब करने का दे दिए साहब, डस्टर थोड़ा डस्टर दे दिए साहब. बस ठीक नहीं. So in this work, the work come in this, the last work we are discussing, in that work all vehicles are considered homogeneous. In this work vehicles are considered heterogeneous. Some vehicles are also considered as a fog device. In my work, some vehicles are also considered as the fog device. So there are 2 types of the vehicles. One is a vehicular fog node and task requesting vehicle, TRV. Task requesting vehicles are normal vehicles. Those have no sufficient capacity to work as a fog device. However, some vehicles have sufficient capacity to work as a fog. So 2 class of the vehicles, normal vehicle TRVs and vehicular fog node, right? So vehicular fog node TRV, that is related. So mobility to this work is in focus of the two issues. One is the mobility issue. Mobility issue is what you see here. Some vehicle, let's say some vehicle, this is a task requesting vehicle. Let's assume this task requesting vehicle offload the task to the roadside infrastructure. Assume, right? Roadside infrastructure, right? So once it offload the task, due to its mobility, these circles are basically the communication ranges, right? Communication range of vehicle, communication range of base station, right? So if this vehicle offload the task to this RSU, due to the mobility, the situation may be there this or sometime this. So what happens, it offload the task to the RSU. Meanwhile, if it do the computation and try to return back the result to the vehicle, it may happen that vehicle is outside in the communication range of this RSU, right? Correct? So if vehicle who offload the task, मैंने कर दिया इस पे और मैं बाहर चला जाऊं and outside the communication range of this room, so there is an issue how we retrieve the result back. That is the loss of packets, loss of task, right? So that loss of the task may be evaluated as the performance of the fog device or performance of the system, right? If you evaluate the overall system, then let's say 100 tasks I offloaded, out of the 100 during here to there I received 10, right? So the performance is definitely 10 by 100, 10%. It is better once I move from here to here, all hundreds are we offloaded, we receive those hundreds. So definitely performance is good of our system, right? So that issue we are trying to tackle. In that situation, what happen if we are unable, our vehicle is outside the range of RSU, then how we tackle this problem? So what the solution we making here, we consider we making some vehicle as a this vehicular fog node. So among the vehicles, right, like let's say simple logic in this problem, some students are very good, they are as similar processing power as of me, right? ऐसे होते क्लास में बहुत सारे स्टूडेंट होते हैं, they are as equivalent to the teacher, right? बहुत अच्छी उनकी नॉलेज होती है, right? So we try to identify those vehicles, उनको हमने अभी मार्क किया, this because this work is a 21 near about, right? So at that time we consider those vehicles are considered as the fog capability. तो उनको हमने कुछ something more computation दिया, so those are considered this. So what happens in that case, once this requesting vehicle outside the range of this, we use these fog nodes, vehicular fog node, to establish the communication with this. So now once result are retrieved back, this node gives the task to this and this gives the task to this, and in this we try to optimize the latency as well, right? Time भी आपका नहीं बढ़ना चाहिए, right? With the both objectives, optimization हमने भी use किया है. So in this optimization we try to minimize this latency as well, correct? So we achieve this problem and then minimize the latency as well. So that is this first issue, mobility issue, that we consider in this problem. Achha. And in this another milestone we achieve, that is that the problem is unawareness of the available computation. Available computation means, just an example, let's say I am busy with some student, right? Just a simple realistic example, just I am engaged with some student, right? Let's say you come and want to discuss something, right? You want to discuss something with your faculty. So what happens? If you don't have information how much time I engage with this fellow, right, then what you do, you can go to some other faculty for your work. Definitely आप चले जाएंगे, but right, and it may possible some other faculty also busy, you move to the third one, right? So what happens? once you come, if you evaluate the time, once you come and once you get your task executed, so that may be very high, because you don't have updated information of how much time I engage with this student. If you know this amount, let's say once you come I am busy, and if you know that I am busy with next 10 minutes, right, then you evaluate that if I move to some other people, more than 10 minutes are required to move that, so why should I go there, right? Why not we wait here? So if that computation time or computation V remains, if I notice and evaluate very well, we can make our system more efficient, right? So 2 milestones we achieve, the communication issues as well as computation issues, and that is called the unawareness of future computation of static fog node and vacuolar fog node. Static fog node, as you see previously, devices installed on the roadside unit, those are static. Vacuolar fog nodes are dynamic, right? So as other vehicle move, vacuolar fog nodes are also move, so they handle the mobility issues very well. These are some numerical examples. So these are some assumption in our problem, and in this there is another change in this work. We are considering the multi-hop as well. So assumption of this algorithm is task processing exclusively carried out by either vacuolar fog node or static fog node. Only 2 types of the fog nodes are considered. They can do the execution, right? RSUs are limited to performing scheduling tasks only. Means roadside unit means static fog node, roadside unit, right? So they need to execute a scheduling algorithm, because what happened, because there are 2 types of the fog devices considered. One is, this is your vehicle, this is your simple vehicle, and this is your roadside infrastructure, right? And some vacuolar fog nodes, these are static fog nodes and these are vacuolar fog nodes, right? Fog node. So if this static fog node generates the task and they offload the task to the RSU, there is a scheduling algorithm, because RSUs have some virtual machines, right? Their own computing availability. So in this problem we are considering I think 20 virtual machines on each computing device. So on this RSU scheduling algorithm is running. That scheduling algorithm decide whether we have to use the computing of RSU only, or there is a requirement to use the computing of the vacuolar fog node, right? That's why it is RSU are limited to performing the scheduling task only. So the role of RSU is only to schedule the task, nothing else. Every RSU is equipped with an equal number of static fog node, denoted as equal now. Heterogeneous environment nahi hai ki some RSUs have different number of virtual machines, some RSUs they are all considered with the same virtual machine. Complete coverage of entire road network. So the scenario is, whatever road network we install sufficient number of RSUs so that we can cover the network road structure very well, right? There is no overlap in the communication range of the 2 RSUs. Overlapping is not be there, right? Means specific type of the overlapping is not be there. Single fog node is exclusively allocated to processing each complex task submitted from the TR, right? Yes, it not be that the same task is offloaded with the more than one fog, right? That is exclusively forwarded to the particular fog node. So to handle the mobility issues, we are predicting the future locations of the vehicle. So the standard mathematics Euclidean distance, right? With the defined angles, we can evaluate the position of the vehicle in another time stamp. So at some time t1 we know the location of vehicle, another time stamp what the location of the vehicle, because road is some wider road, so angles may be changed by a vehicle on the road. So we evaluate this Euclidean distance in the angle format. So that is the future distance on some t2 time of the vehicle, predicting the position of the vehicle. This is the imminent computation capability. That means we are trying to achieve the knowing the what the computation available on the fog node, so that we can do this, right? Try to achieve the real time computation. So mathematically they evaluated. So you see this computation capability is a processing capability of the fog node at some imminent time tau. Imminent tau time is what? Next time, right? Means if at that time, right, what would be the computation available in next 10 seconds, 10 minutes, right? If it is feasible to know that, the work is job, because we can wait only for 10 minutes, right? Because every task has the defined deadline. भाई आपकी भी तो एक पेशेंस की लिमिट है ना, आप कितनी देर बाहर वेट करेंगे, अदरवाइज आप भाग जाएंगे, कहेंगे किसी से मुझे कुछ नहीं चाहिए. That is the simple theory, right? So there is every task has a defined deadline. Within that deadline, if the things are executed, means within that defined deadline we try to identify, right? After that time, means if the deadline is, let's say, your 10, so in the next 10, whether I am free or not, means what the after 10 minutes or 10 seconds, what the remaining computing available with me, then only you can facilitate. तभी तो मैं facilitate कर पाऊंगा. कंप्यूटिंग ही नहीं होगा, मैं खाली भी होगा, बट कंप्यूटिंग खत्म है, तो फिर क्या है, मेरा मनी नहीं है, आपको कंप्यूटिंग खत्म, right? How we can facilitate? So we try to find out in the next time, predicted time, and this tau may be variable. एक बार हमने कुछ फिक्स वैल्यूज के लिए इसको इवैल्यूएट किया, then accordingly we do with other taus, right? उसको हमने अचीव किया है, and this mathematical evaluated. So number of available VM capabilities will be free at the future time. So उसको हमने लिया है, VMC is the processing capability of VMs, because every static fog node as well as the vacuolar fog node have the VM capability, number of VMs, right? जो computing देंगे, right? And this, so this is how this is evaluated, this mathematical evaluation, how this in the future time, what the computation available. So this is sum up, summation function 1 to m. This is the processing capability of VM, and this is VMC is the status, right? Right? VMC is the status of the ith VM of fth fog node at time tau, means status, right? Whether it is free or not. Free means 1, not means 0, right? So let's say 10 VMs are there, sorry, 10 fog nodes are there. Let's say this fog number 1 is free, so this value is 1, so corresponding, this value is 1, so corresponding computations are accumulated. Next one is busy, 0, the contribution of that is 0. Third one, so similar way, if you accumulate for the whole scenario, you find the total computation in next time, because multiple scenario, no? Multiple fog node and multiple, right? So overall total computation, we are evaluating the total computation, because multiple tasks are there. So total computation we evaluated, total available, this is the total available at the next tau time, right? And the total input means total capability required by the processes. If it is okay, then we can go ahead, we can utilize the capabilities. Time कितना हुआ? अच्छा, बस थोड़ा सा लंच हो गया क्या आपका? लंच टाइम? अच्छा, just 5 minutes. This is another parameter, sum of offloading delay. Sum of offloading delay. Offloading delay means amount of delay involved. Just 5 minutes. Offloading delay, right? Every task is each vehicle as a summation total offloading delay. So इसको भी हमने किया, sum of offloading delay, amount of offloading delay on the fog nodes, sum up with the all available fog node, then total offloading delay. Just 5 minutes, please. Just 5 minutes. This is another parameter that we consider in this sum of offloading delay. Latency, जिसको अभी हमने last time में latency कहा था, that is an offloading delay. That is named in our work, that is an offloading delay. So overall, in terms of the system, total offloading delay. So across the different fog nodes, whatever the delay we perceive, if you sum up, then total system offloading delay we can evaluate. average load variance, because another objective in this, fog node must not be overloaded. So variance in statistics, there is a variance, right? So we evaluate the average variance, right? Means average variance, actual required one, what allocated, so the difference in that one, right? Handling capacity of the fog node, variance यही होता ना, standard variance in the statistic, data variance. This is actual value, this is actual, and this is whatever you have perceived, right? So the difference, right? Standard deviation और variance, उसको square कर देते हैं, you get the variance. Plus minus, जो भी आप plus minus करते हैं, right? Plus minus limit, समझ रहे हैं ना variance, right? So actual handling capacity of the fog node and number of tasks allocated to that fog node, the difference, that is called the variance. So corresponding to every fog node we evaluate the variance, and if variance is reduced, we can say our system is better. If variance is very high, that means the indication is that variance is very high, that means some fog nodes are heavily loaded, some fog nodes are less loaded. यही तो होगा भाई, किसी पे वेरिएंस, अगर डेटा में आपका वेरिएंस, डेटा साइंस पढ़ी रहे, डेटा प्री प्रोसेसिंग, राइट? भाई डेटा का अगर वेरिएशन बहुत ज्यादा है, देन व्हाट यू एनालाइज विद दैट डेटा, data is not be a very good data, many of them are outliers due to the high variance, right? The same approach is here. If variance is very high, that means some fog nodes are heavily loaded, some are less loaded, right? So we evaluate the average load variance of your system. Accordingly, we say what the exact situation, whether it is a good system or some lacking there. Within range ratio means out of the total task offloaded, right, by some vehicle, how many vehicles are remain in the communication range while at the time once they receive the data. Within range ratio, right? Within range, हमने upload कर दिया, and how after uploading how many tasks we received, that is within range, right? That is within range ratio. So they mathematically they evaluated successful offloading ratio. Successful offloading, out of total offloaded, how are successful. Successful means getted the result back within their defined deadline. Successful offloading. So using these parameters, these desired parameter, because our focus in, we have to optimize the system across these dimensions. That simple objective जो हमने problems आपको बताए. So we consider the, उन्होंने अभी जो पेपर इससे पहले डिस्कस किया था, they optimize the trade off only the latency as well as resource utilization. Here we consider the mobility as well. So that's why sum of offloading delay, one parameter, that is a latency, right? Average load variance, fog nodes are heavily loaded or less loaded, right? That parameter is considered to design this system. Average load variance at t time, current load variance, tau time, futuristic load variance. So based on these two, we can say whether nodes are heavily or less loaded. And this is a WRR, range ratio, sum of offloading delay. What the SOR is? Successful offloading delay, yes. And WRR is within range ratio, yes. So this within range ratio, so as many vehicles are within range ratio, that is good for our system. And sum of offloading delay, that must be, right, delay must be minimum. That's why these two parameters, because overall objective to minimize this function, that's why these two parameters, because our objective is, right, these three are minimum, but these two must be high, right? Success, because our objective is successful offloading must be high. Within range ratio means as much vehicles within the range, right? So उसको हमने minimization functions था, that's why they are considered in the negative direction. बोलिए, you solve any optimization problem? If you solve any optimization problem, why we need the optimization? Because this is not a single variable problem. जब आप बड़े सिस्टम में once you work in some big system, your dimension is very high, right? कई सारे dimensions हो जाते हैं, ठीक है? जैसे if you selected in your placement drive, so their objective is what? Student CPI is very good, student good in the curriculum activities, student must good in the sports activities, right? Let's say 3 dimension, and on the basis of these 3 dimension we evaluate the student. So हमें optimization लगाना पड़ेगा, right? Because some student may be good in the CPI, some student may not good in the sports. Out of these we have to find out, right? So we have the good optimization algorithm, they are working very fine, और वो तुरंत फिल्टर करके आपको बेस्ट स्टूडेंट दे देंगे अंडर डिफाइंड कंस्ट्रेंट. डिफाइंड कंस्ट्रेंट क्या है कि भाई डिफाइंड कंस्ट्रेंट में भी CPI नॉट लेस देन दिस, राइट? स्पोर्ट्स में जो भी आपकी ग्रेडिंग हो, स्टेट लेवल प्ले किया है, सेंट्रल लेवल प्ले किया है, जो भी. सो अंडर डिफाइंड कंस्ट्रेंट, बिकॉज कंस्ट्रेंट्स आर इंपॉर्टेंट, राइट? सो multiple dimension, multiple constraint. So that's why in that situation we need to use the optimization algorithms. Here the same is, we have a system, and with that system we need to optimize these variables, right? Your CPI is a variable, right? CPI is your variable, right? Co-curriculum activity is another variable. Similar way, here 5 variables are there, right? Under defined constraint. Defined constraints are written here. ODI, right? Sum of offloading delay must be positive. Your load of variance must be always equal to 0 to 1, right? Your WR 0 to 1 within the range. These values are this range. So constraints are given. Under this constraint, if you have multiple dimension, how you get the best result, that is the objective of optimization problem. So this is a complete area, like your data science, machine learning, optimization is a complete area. So many algorithms, using that algorithm you can get the good result. So I think it's over. So all about from my side. If any question from your side, you can ask. And this is very useful in nowadays, because things are in the transportation sector, things are changing very rapidly, बहुत ज़्यादा दिन नहीं है. I think in next 10 years you see the same application in India as well, right? Where you sit in your car and nothing you have to do it, right? Okay, thank you.
Thank you very much, sir, for such an informative and engaging session. Your explanation of how blockchain and fog computing can integrate to create secure, efficient, and scalable networks has certainly provided us with all deeper understanding of the futuristic domains. Thank you very much, sir. May I now request Professor Brijesh Kumar Chaurasia, sir, Dean Research and Startup, to kindly come forward and present a token of appreciation to Dr. Dinesh Singh, sir. Thank you so much, sir.